Hey there, this is Akshit Madan. Welcome back to a new video. And in this video, we are going to study abstract classes. And to understand it, you also should be knowing about abstraction, right? So, if you already know about OOP concepts, the object oriented programming principles, then you are already aware about abstraction, right? So, in simple terms, abstraction means to hide the implementation details from the end user or from the end programmer, right? So if I create a class, let's say electronics, then I can create an instance of it, right? So let's create it. Let's not just talk about it. So I'm going to create a void main function, and below this I'm having a class electronics, right? So if I create electronics class and every electronics item, so this is electronics item class, every electronics item is going to get watched, right? Let's say it is a TV or it's a mobile phone, it is going to get watched. That means it has a function of watching, right? Someone can watch it. So void watching, and this is a normal function inside it. And I can say that I can print something inside it. Item is getting watched. Item is getting watched, right? So this is a normal function and we already know about it, that we have defined a class, and over here I can create the instance of this class, right? So I can say electronics item over here, electronics item, this is the object name, is equal to electronics item, right? And like this I have created the instance of this class. Now to study about it, or whenever if I create another class, let's say a mobile phone, and obviously this mobile phone is going to extend this electronics item, right? Simple inheritance concept we already studied about in the previous videos, right? This is going to extend my electronics item, right? But now in this mobile phone, if I create a class, now I don't know which all methods are there in this electronics item. I have to go and read this electronics item class also, right? That means the user, the programmer, has to understand this electronics item to create the functions or to create anything inside this mobile phone class. That means the implementation of this electronics item is not hidden from the end programmer or the programmer who is coding this mobile phone class. Or I can say that he has to still worry about this class also, the parent class, right? This is my parent class, right? And this is my child class. So if next time I create a TV class, then again I have to see what's inside my electronics item class, right? So that I can understand it, and then I can create all the methods and functions inside it. But what abstraction says, that if you define this class as abstract, right, then all of the implementation, like whatever implementation is there for this electronics item, is hidden from the end programmer. You do not need to worry about it, right? And to now you will see the magic, right? I'm going to hide this, or I'm not going to write this implementation of this watching function over here, right? I'm going to just define the method. And to define the method, what have I done? I've just defined the void, the return type, and I have just defined the name of that function and this circular brackets. I did not write this, or I did not write anything inside this function, right? I just defined the name of this function. And as soon as I did this, this mobile phone has started giving me the error. It is saying me that missing concrete implementation of electronics item watching. That means this function is missing. So if I just made this class as abstract, that means I don't want to get inside this class and read about it. All the abstract methods. So this is an abstract method, right? This is not a normal function. I will show you what a normal function will look like, right? This is an abstract method. It is going to suggest me that, hey, you have not defined the watching function inside it. So now I can understand, hey, if I am extending this electronics item, that means every electronics item is going to have a watching function. That's obvious, right? You cannot have an electronics item without getting watched, right? So over here I can define my watching function, same name, right? Same name. And over here I can define the implementation of it, right? I can write print watching, right? This is the implementation. Now some functions can be something like that which do not need the implementation to be there in the child class. Like in mobile phone class, I don't want to like write this function. I want that if I extend a class, if I extend the electronics item class, then I should get those functions itself, right? So let's say function 1, right? It can be anything. For that, you cannot just define the name of this function, right? This should not be an abstract method. If you define it like that, then you have to define the implementation of it in your child class. So over here you need to define a normal function. All the normal functions, if you define a normal function, then it won't give you any error in the mobile phone class, right? Because this is just a normal function. I can just define, hey, like print function 1, right? Print function 1, just like this, right? I can have another function, something like this, and I can make it function 2. I can make it function 2, and this is also a normal function. But as soon as I define another function, which is an abstract method, it can be watching 1, then it is going to give me an error over here. It is going to say, hey, you just defined the name of this method, but where is the implementation? I don't know where it is implemented, right? So I need to define the watching 1 function also, right? So this is how abstract classes work. One more thing, you cannot create an instance of the abstract class. If I remove this abstract from here, then yes, you are going to create, you can create the instance of this abstract class, but then abstract methods are not going to work. You have to define the implementation here itself, right? So this is how the abstract classes work. I hope you understand the significance of abstract classes. So whenever we just want to create the blueprint, let's say I am creating an animal class. Let's take one more relevant example, right? I am creating an abstract class animal, right? For an animal, yes, we have legs, right? Animal has a mouth, yes, so these are the variables, right? And we can say animal is going to definitely have a color, and yes, you need to initialize it. So let's say 4 legs, mouth, let's say 1 mouth, and we definitely need to have a color. So let's say string color is equal to, let's say, red, right? And then we can have some functions. So every animal is going to walk, so void walk, or let's say voice. What voice does that animal take out, right? So void voice, and that's it. You cannot just define the implementation of this voice method here itself. Every animal is going to have a different voice. So I can say that I can just define the name of that method, but I cannot define the implementation of this method, right? So now if I define a class cow, right, and I extend it to my animal class, then I have to define this voice method over here, right? So void voice, and I can define print moo, right? This is the voice that a cow takes out, right? And as soon as I do this, the error is gone, and I can create the instance of this cow class. That's it, right? Now you can have another class. You can have a cat class. Same thing. And here the implementation of voice is going to be different. It is going to be mew, right? So this is how things work with abstract classes, and the simple significance is a blueprint of the class, and other classes are going to extend this abstract class and they are going to have a different implementation. Then yes, you can use the abstract classes, and this is how abstraction works. So I hope this was clear. Till the next video, keep coding, keep innovating, and thanks a lot.